Assalamualaikum warahmatullahi taala wabarakatuh. My name is Siti Hajara binti Abdul Aziz Krish. My metric number CE190033 and I'm from group A 4.5. So today our group will present about the AC Three-Phase-2-Pole-Synchronous motor. First of all, let me introduce our group members. Number 1 is me, Siti Hajara. Number 2 is Sharifah Nur Afrina binti Said Yusof. And number 3 is Wong Ching Kang. I will explain about the equipment layout in star wiring. In this activity, we use three-phase supply. That is called as a power meter, and we use 4 power meters to measure the voltage, the current, the power and the power factor. At the power meter, we must set the selector at the 4 wires because we use the red, yellow, blue and neutral wires. Next, we use a DC meter for voltage, for current, DC supply, and digital DC for ammeter and voltmeter. For the connection, the red, yellow, blue, and neutral will connected in series to the 4 power meters. The power meters get the supply directly from three-phase supply when we turn on the three-phase supply and we increase the voltage. And then at the power factor, the red, yellow, blue and neutral will supply to the stator to create the electric magnetic force of 2 poles configuration in stator. Next, the excitation at the rotor side will get the supply from the DC supply. And DC supply also connected to the DC voltage and current. In DC meter, we use the analog voltmeter and ammeter. So for the voltmeter, we must connect in parallel with the digital voltmeter. While for DC ammeter, we must connect it in series to digital ammeter. And then the common at the digital ammeter will connect to positive side polarity of the carbon brush. And then the negative side will return back to the negative power supply. In star connection, the red, yellow and blue will connect together as a common and go back as a neutral at the three-phase power supply. That's all from me. I will pass the next explanation to the next presenter. Thank you.
Assalamualaikum. My name is Sharifah Nur Afrina binti Said Yusof and my metric number is TE190146. So in this video, I'm going to show the connection of the equipment layout for the delta configuration. So basically, the connection of the star and delta configuration is almost the same. The only difference is at the incoming and outgoing power supply. So the equipment that we will be used is three-phase power supply, digital power meter we will use for voltage, current, power and power factor. Next, we need a DC supply and also DC meter, DC voltage and DC current meter, and we will also need a digital DC meter for ammeter and also voltmeter. So for the connection, the red, yellow and blue of the incoming supply, which is from the three-phase supply, will be connected to the digital power meter. So the red phase will go to red, yellow will go to yellow and blue will go to blue, and each of the power meter will be connected in series to each other, and the outgoing of the digital power meter will be connected to the stator. So the red phase will be connected to the red, the yellow will connect to the yellow and blue will connect to blue. So for the delta connection, the outgoing supply of the red will connect to the incoming of Y, of yellow, and the outgoing of yellow will connect to the incoming of blue, and the outgoing of blue will connect to the incoming of red. Thus, the EMF will be produced at the two-pole configuration in stator. So for the excitation at the rotor side, it will connect to a DC supply from the DC power supply here, and the DC power supply will be connected to the DC measurement meter, which is volt and ammeter. So for the voltmeter, the analog voltmeter will connect to the digital voltmeter in parallel, while the DC ammeter, the DC analog ammeter will connect to the digital DC emitter in series, and then the common at the digital emitter will be connected to the positive side of the carbon brush, and the negative side of the carbon brush will connect to the negative power supply. The negative side of the DC voltmeter is also connected to the negative power supply, DC power supply. So that's all for the equipment layout for the delta configuration. Next, I will explain about the connection for the stator layout for the delta configuration. So for delta connection, the connection of the stator is also same as the star connection, because it still apply the same concept in order to create the two-pole three-phase motor. So we just need to rearrange the connection from the incoming as well as the outgoing. So as you can see here, from the three-phase supply, red will be connected to red, and it will go to the first pole 6 and then to 7, and then from 7 it will go to 1, and from 1 it will go to 12. And the 1 and 12 is the second pole, and then from 12 it will go to the outgoing of the red line. So the outgoing of red will connect to the incoming of yellow, and then from the yellow it will go to the first pole of yellow, number 10, and then from number 10 to number 11, and from 11 it will create the second pole at 5, and then to 4, and from 4 it will go out to the white outgoing, and from the outgoing of white it will connect to the incoming of blue, and then from blue it will connect to the emitter, and emitter will connect to the blue phase, and it will connect to 2, and from 2 will go to 3 for the first pole, and for the second pole 3 will connect to 9, and 9 will connect to 8, and from 8 it will go to the outgoing of blue, and the outgoing of blue it will connect to common, and also it will connect to the incoming of red. As for the voltmeter, it will connect to between red and yellow phase. So this is the power supply. The emitter is connected in series, and the voltmeter is connected in parallel. So from the DC power supply, the emitter will go to the positive carbon brush, and the negative carbon brush will go to the negative side of the power supply. That's all from me for the stator layout connection. Next, I will pass to the next presenter. Thank you.
Hi Doctor, my name is Wong Jin Kang, can call me CK. My metric number is AE180110, and now I will do the presentation for the graph. The first graph is the calculated horsepower versus the load torque. This is the graph. The blue color indicate the star connection, and the orange color indicate the delta connection. From this graph, we can see that the both star and delta connection show the increase almost linearly as the load increase. And now I will do the presentation for the second graph, which is the AC current IAC stated in three phase with the red, yellow, blue versus the load torque. This is the graph for the star connection, and there are three colors in this graph, with the red color represent the red phase, the orange color will represent the yellow phase, the blue color will represent the blue phase. And this is the graph for the delta connection. In this graph also have the three color, and the color also same with the graph of the star connection, and the meaning also same with the star connection. And in the graph of the star connection, we can see that the red color with the red phase has the higher AC current value, and in the graph of delta connection, we also can see that the red color has the red phase also has the higher current value in the between the other phase, so that we can conclude that in this both connection, the star connection and the delta connection, the red phase has the higher current value, and at the same time we can see that the delta connection has the higher AC current value than the star connection. And now I will do the presentation for last graph with the DC current IDC amateur versus the load torque. And this is the graph. First we see the color. The blue color is indicate the star connection and the orange color which indicate the delta connection. At this graph, we can see that the star connection has the higher DC current value, and for the delta connection, we can see that the DC current value for the delta connection is nearly constant. And that's all my presentation. Thank you.